I hope we will have the same kind of relaxed atmosphere this coming hour that it was on Saturday when I was here listening to jazz. And that we will have some great interaction between the speakers and the fantastic audience. First, I want to introduce myself. I'm Kristina Blomqvist. I work for the MSB, the Swedish Civil Contingencies Agency, where I manage our program on increased security in industrial control systems. Then I would like to introduce Anders Östgaard, one of my colleagues, and he will make a speech about study about building automation that we initiated earlier this year. We have liked to do this study for quite some time, but sometimes you have to have some help from the media to get things going and get the resources to do it. So that brings us to our second speaker this afternoon, but we will get back to that later on. So Anders, welcome to the stage.
Thank you. I hope we get this to work this time too. Sorry for that aspect. I'm Anders Östgaard. I work as the MSB. I need to present an overview of this pre-study that was made. We received it just a month ago. I have a background in biomedical equipment and medical information systems, so sort of make me approach this from the OT side. This study was initiated, as Kristina said, by MSB. It was written by FOI, which is the, I think this, is it okay? Yeah. Yeah, it goes off and on. Maybe it's, I should turn my head too much. It was written by FOI, which is the Swedish Defense Research Agency, and writers there are Karin Mossberg-Sonneck and Fredrik Lindgren. None of them were able to be present here today. So I would make this presentation from my view as a receiver of this study. The study itself is not very technical, so this presentation won't be very technical either. It's more from a general standpoint on how you can make your security better in building automation. A short presentation of the MSB program. We have a program for increased security in industrial control and information system. It contains of 5 major areas. This presentation will connect to 2 of them, mostly the NCS3 and our guide to increased security. I will come to that later. Short introduction of NCS3. It's a collaboration between FOI and MSB. It's a competence center. Our cyber range and training environment are located there, and we use it for training. There are currently 2 courses, one basic security and one course which is a little bit more advanced practical incident handling and critical infrastructure control systems. So let's get back to the study itself. The two purposes to this one. The primary one is to give an overview of building automation in Sweden, and especially with the buildings containing critical societal functions. A secondary objective was to describe concepts used in the field and how they relate to the concepts which are used by MSB. The method used, literature, study, and interviews, and the operators selected for this interview. They should be some way related to critical societal functions, and they should have distributed properties so they could have an incentive to centralize their monitoring and control systems. So what is building automation? On my spare time, I spend a lot of time drawing circles. That's because I have a 2.5-year-old daughter who also likes to draw circles. But I think this is, I quite like drawing circles to describe things and how they connect to each other. And as I see it, building automation is a subset of industrial control systems, and another subset of that is access systems. Access system is not included in this study. And I also put the circles, technically they are ellipses, you know. But I put them a little bit outside. It's more a defensive approach. But you could argue if they should be inside the ICS circle or not, but that's another discussion. A little more practical approach. What is building automation? Mainly HVAC, heat, ventilation, and air conditioning, and systems for elevators, escalators, fire alarms, which connects to the video we just saw here. I hope that it didn't trigger the fire alarm, but it took care of it anyway. Sunscreens and automatic lighting is typical systems that we're talking about. And if you take the definition more from a person's view, this is how one of the respondents described it. Equipment that happens to be IT equipment that will be sold as part of the house in case of sale of the house. And especially this happens to be IT equipment. I think this is quite important, this quote, because this sort of sets the tone on how many of the operators look at these issues. We get into similarities now with classic SCADA ICS, and there is a cultural difference in many cases between OT and IT. And if you want to improve your security, you have to understand this mindset to work with these operators. And this is this discussion of operation efficiency and availability versus security. I know security could have an impact on efficiency and availability, but this is sort of where you start your thinking. It's maybe from different approaches. I think Ariane Mayer talked a lot of this yesterday in his speech. I will continue with similarities and with classic SCADA ICS, and I will then show some differences. There is an increased usage of commercial off-the-shelf. These systems are more and more connected to administrative networks, but this study also showed that there is a large variance. There are operators which have that have a total separation, and the operators who have a total integration. So it's quite hard to say that this is the case. It's more like there are many solutions to this. And the typical data to transfer is use of energy, and that is also the typical incentive to centralize the systems, because it's quite easy for you to get payback on if you reduce your energy cost. Long life cycles in these systems, 10 to 30 years. Some of the systems in the study was about 60 years. I don't know how digitalized those systems are though, but this sort of sets, buildings are meant to last in some way, and probably the systems in them too. Go back a little to the mindset and the culture. Patching in these systems, mostly based on function, not security. Test environments, this is another quote I like from one of the responders. As it happens, it's the supplier that utilizes the testing environment, not us. And that sort of make it a development environment, I guess. Maybe a little bit immature way of handling your environments. But I know it myself from biomedical equipment how you don't always have testing environments in all cases. So it's a step even to have one. Security aspects, increased exposure via network, and long life cycles and lack of patches. In this audience, that is a no-brainer that we have an increased vulnerability. The operators are working with security aspects, mainly authorization and remote access. So there is some work with this, and the third part here is important. I may sound negative in some cases, but the variance here is large. We have those that are very aware of these issues, and there are those who are not aware of these issues. So it's quite hard to say that this is how things are. It's more like how they can be. And as many respondents pointed out, these systems are in many cases autonomous, which to some degree could mitigate the vulnerability. They are not dependent on the layer above them. They could still function, but in many cases, this workaround has to be carried out by a technician, and then you could have this discussion if you have a huge problem, do you have manpower enough to handle it? Another issue that the responders lifted, and was also a case for the study, was that the concepts differ. You're not supposed to see this in detail. You can see it in the report if you want, but and it's in Swedish too. But it shows that different operators have different terms when they speak about this. The terms could, of course, be mapped. But this is a barrier for an efficient discussion regarding, for instance, safety issues. Similarities, this is a summary of what I said. What could be more interesting is the difference, which is pointed out, and that is that the owners, operators, and the users are in many cases not the same organization. Ownership changes, buildings are sold, operators changes, a typical contract could be 1 to 3 years, and then you have 1 or 2 year extension of that contract. And the users could also change, which has the demands. And since buildings in many cases are old, the systems are installed at different times, they are installed from different manufacturers. So you have this patchwork of operators and you have this patchwork of systems, which makes for quite a complex environment to handle. And the responders expressed that there is a demand for more consensus about appropriate safety levels, including requirements in procurement. Now they want a more standardization on how safety could be handled when you buy new systems.
Do you really intend the word safety here, or do you intend the word security?
Sorry?
Do you mean actually safety, or do you mean security?
In this case, safety.
So personal lives. Safety of the persons working there.
Safety of the systems.
No, that's not safety, that's security in English.
Oh, sorry. I meant security, you're right. As we discussed it earlier, but this is a slip of mine. And for the non-English speaker here, in Sweden we have SCADA here, and that could be translated into both safety and security. but there are totally different aspects. Thanks. They also expressed a more unified demand for more unified concepts within the industry, so that you could ease discussions. And there was also this demand for continuous education regarding security aspects. I added this yesterday when I got my daughter into bed, which was a bit of a project yesterday. What MSP will do next in this, we want to follow up this pre-study with a theoretical reference environment that could be a little more technical description of how these systems could look like in reality. We also want to add a layer describing responsibility, and especially that this could be applicable to public sector, which we are interested in. We will also find which of our recommendations in our guide to increase security that is most applicable to building automations. And I will get now into our guide. I think you have got it in your orange bags. There is a Swedish version of this one too. You can find it at msb.se/SCADA. It contains 7 clear recommendations with suggestions. It is free. It is a collaboration between a lot of Swedish agencies. And it will, if you follow these, you will, at least in the long run, have an increased security in your systems. These are systems, your recommendations. You're not supposed to read them here. But I will now go through 6 of these recommendations, which I think is more applicable, and I really like input on those, because they're still work in progress, so it could be changed. The first one is to ensure that you have a systematic change management. In this complex patchwork of systems and operators, I think a systematic change management is the only key to know where your system is at this moment. Of course, you have to know the starting point, but then how it evolves. You should also introduce security right from the start in all planning and procurement. That may be easier said than done, and the respondents also expressed there is a need to do this. And as we discussed over lunch, sometimes it's not only to make requirements on what you want, sometimes it's also, at least it is important to describe what you do not want. Because in many cases, you could get functionality which is sort of, you get more functionality than you really want, and if you're not aware of it, then it could be a security issue. You should have a security architecture that goes well in hand with your requirements. If you have this architecture, then you have a much easier time to make the requirements. Conduct regular risk analysis. This is sort of the engine in every risk management system. So you should know what problems you are facing and which one of them you prioritize the most, so you could start handling them. Connections should be relevant and to some degree secure. You have at least to balance the need for connection from the outside to a certain level of security. And you should be aware of them, of course. And the last one is harden and upgrade your systems with vendors. I think the key here is to do is with the vendor, otherwise you're on your own, and it could be a lesson learned for both. I know this could be quite hard because in many cases I think the vendors, manufacturers will just say, no, this can't be patched. So maybe easier said than done in this case too, but you have to keep asking, I guess, and if many customers ask, then maybe things will change, you know, utopian future. Another thing, if you don't want to patch them, I know the hospital in Uppsala is also working with whitelisting. They have a project going on there. They use a whitelisting software, which more tells how these systems are allowed to run, because they have this issue that you can't patch them. So the conclusions from this, there are many similarities with classic ICA SCADA. The thing that differs the most is the preconditions. This patchwork I was talking about with the different operators and different systems. The variance is large, so it's, especially from this study and in general, I think it is quite hard to say that this is the state of building automation in Sweden. And the final conclusion is that the MSP's guide is applicable. The concepts differ, which will make it maybe a bit harder to understand in the beginning, but it is applicable. And we will try to write something that is more turned to the building automation sector. And if you have input on that, please give them to me.
So, thank you, Anders. If you can stay on the stage. I happen to know that Tommy is in the audience, and he works for quite a special real estate company. And I would just like to ask you if you have